So this lesson is about the binomial theorem. Binomial, of course, is a polynomial with two terms. We already know how to do a binomial square, which is a squared plus 2ab plus b squared. We also know how to do a binomial cube, a cubed plus 3a squared b plus 3ab squared plus b cubed. The question is, can I do a plus b to the n? And I'm, for this lesson, going to stick with n being a positive integer. So that's what I'm trying to find. Is there a formula that I can use for any positive integer n? And it turns out there is. I want to point a couple things out really quick about this. First of all, the exponents of a are going down, so a cubed, a squared, a, and then nothing. And the exponents of b are going up, nothing, b, b squared, b cubed. Same thing for the binomial square. So that's a pattern we're going to keep going as we move forward. So for example, let's look at a plus b to the 8th. What that really means is a plus b times a plus b, etc., 8 times. So there's 8 of these a plus b's being multiplied together. And any term that I end up with when I'm done will select exactly one of the terms from each of these factors and multiply them together. So for example, one of the terms I could get would be if I selected this A and then this A and then this B and then this A and then this B and then this A and then this A and this B. So that would look like that. That has 8 total A's and B's, and it's just one of the possibilities of the multiplication going forward. Now this particular one is going to end up with a to the 5th times b cubed. And of course I know there's a bunch more before and after it, but the thing is, it's not the only a to the 5th b cubed I can get. There are going to be a whole lot more like terms depending on where I pick my a's and my b's. In other words, different arrangements of these a's and b's. Wait a minute, I've done that before. That would be 8 factorial for the total number of letters divided by 5 factorial because of the a's times 3 factorial because of the b's. And I'm just trying to find how many words, quote unquote, I can make with 5 a's and 3 b's to get my a to the 5th b cubed. So this is the number of different arrangements I could use to get my a to the 5th b cubed. But you might recognize this. This is better known as either 8 choose 5, 8 factorial over 5 factorial times 8 minus 5, which is 3 factorial. Or it could also be 8 choose 3. 8 factorial over 3 factorial times 8 minus 3, which is 5 factorial. So either 8 choose 5 or 8 choose 3 is an alternate way to write this. So what I'm saying is that if I took my a plus b to the 8th, I know there's a bunch of terms here and there's a bunch of terms here, but the term that involves a to the 5th b cubed could be written as 8 choose 5 or 8 choose 3, really wouldn't matter, times a plus a to the 5th b cubed. So the coefficient would be 8 choose 5, or again, 8 choose 3. So now I'm going to summarize that into a formula. So this is the binomial theorem, again, for n in z plus. If I have a plus b to the n, it's going to be the sum of all of these. So we start at r equals 0, we go all the way to r equals n. This is a total of n plus 1 of these, starting at 0, going to n. And we do n choose r, and then we do a to the n minus r, and then b to the r. So the a exponents go from n down, so n minus 0, n minus 1, n minus 2, all the way down to n minus n, which is 0. And the b exponents start at 0, b to the 0, and then b to the 1, and then b to the 2, etc., until they get to the b to the n. And the coefficients are n choose r, because we have r of the b's and whatever's left over, n minus r of the a's. You could also do n choose n minus r, but why would I write it more complicated? So this is the binomial theorem. This gives us every single term of that expansion. So now let's expand x minus 2 over x raised to the 5th. Well, first of all, I'm going to do it sort of the quote-unquote hard way. I'm going to say this is 5 choose 0 times x to the 5th plus 5 choose 1 times x to the 4th times negative 2 over x to the 1st plus 5 choose 2 x cubed negative 2 over x squared. And I'm going to go to the next line, plus 5 choose 3 x squared negative 2 over x cubed plus 5 choose 4 x to the first negative 2 over x to the fourth plus 5 choose 5 x to the 0, I'm not going to write, and then negative 2 over x raised to the fifth. Now I need to calculate these coefficients and then of course distribute, etc., etc. So let's just focus on the coefficients first. Well, 5 choose 0 is 5 factorial divided by 5 factorial times 0 factorial. It's equal to 1. 5 choose 5 is also 5 factorial divided by 5 factorial times 0, also equal to 1. So this first coefficient here is a 1, and then I have x to the fifth. And then the last coefficient is 5 choose 5, which is 5 factorial divided by 5 factorial times 0 factorial, which is also equal to 1. So at the very end, I will have a plus 1, and then negative 2 over x raised to the fifth. Now let's look at the second coefficient. That's 5 choose 1. Well, 5 choose 1 is 5 factorial divided by 4 factorial, 1 factorial. The 5 factorial, 4 factorial almost cancel, leaving us with 5 over 1, so 5. So plus 5, and then I'm left with my x to the fourth times negative 2 over x raised to the first. Now the second to last, the 5 choose 4, is also 5 factorial over 4 factorial, 1 factorial. So again, most of it cancels. We're left with just 5 over 1, so 5. So we have a plus 5. And then we have x to the 1, and then negative 2 over x raised to the fourth for that one. Now it's the ones in the middle that are a little more complicated, so I'm going to rely on my calculator. So 5 choose 2 is going to be 10, so plus 10 times the x cubed negative 2 over x squared. But 5 choose 3 is also going to be 10 because 5 choose 2 and 5 choose 3 are the same thing, because 5 factorial over 3 factorial, 2 factorial, or 5 factorial over 2 factorial, 3 factorial. So this is also a 10, but now it's times x squared times negative 2 over x cubed. And so now I can simplify these out. So the very first term will be x to the fifth. The second term will be 5 and then times negative 2, which is negative 10, and then x to the fourth over x is x cubed, so minus 10x cubed. The next term is 10 and then negative 2 squared is 4, so 40 x cubed over x squared, so 40x, so plus 40x. The next term is 10 and then negative 2 cubed is negative 8, so it's minus 80, and then x squared on the top, x cubed on the bottom, so it's minus 80 over x. The next term is 5 and then times negative 2 to the fourth. Negative 2 to the fourth is 16. 5 times 16 is positive 80. And then I have x on the top and x to the fourth on the bottom. So plus 80 over x cubed. And the last one, well, negative 2 to the fifth is negative 32 and x to the fifth on the bottom. So minus 32 over x to the fifth. And that is finally the binomial expanded out. Okay, find the seventh term of this binomial expansion. Now remember, the first term of the binomial expansion has all 14, 3 to the x to the 14th, and then nothing from 4 over x squared. So the seventh term will have 8 of these and 6 of these. So you got to be a little careful with that. So we're going to have 3x raised to the 8th, and then negative 4 over x squared raised to the 6th, because 14, 13, 12, 11, 10, 9, 8, that's the seventh term. And so the coefficient here is going to be, well, either 14 choose 8 or 14 choose 6. It doesn't really matter which one you do because it's going to be the same either way. So now we're ready to do the calculations. We plug them into our calculator. So the 14 choose 8 turns into 3003, and the 3 to the 8th is 6561, and of course then I have x to the 8th. And then when I raise the negative 4 raised to the 6th, it turns positive, so 4096. And then divided by, when I do x squared to the 6th, I get x to the 12th. And now I got to multiply these out. Now the calculator gives me this. This E means exponent. So really it's 8.07021857 times 10 to the 10. That's what that means. So I have, now this has to be rounded obviously. It ran out of space to give me the full decimal. So this is what we got. 8.07021857 times 10 to the 10. And then when I think about the x's, x to the 8th over x to the 12th, so it's all over x to the 4th. So that is the 7th term of this expansion. Now let's hope that we don't get too many of these where we have to do rounding, because I'm not really happy that I had to round this because it had to give it to me in scientific notation. But it is what it is. So now in the expansion of x squared plus 4 over x to the 12th, we want to find the coefficient of x to the 9th. Now, I'm going to start by focusing only on getting x to the 9th and ignoring the coefficient. So I'm going to say, I know there's an NCR coefficient, but there's also going to be an x squared to the something, I don't know, let's say r, and then there's going to be a 4 over x to the, and then that's going to be whatever's left over, so 12 minus r. Now I'm also going to ignore this 4 initially when I'm just trying to get x to the 9th. So when I put this together, I'm going to get x to the 2r will be in the numerator coming from this, and then I'm going to have x to the 12 minus r coming from this expression. Now when I put these together, I need to subtract top minus bottom and get x to the 2r minus and then 12 minus r, which of course turns into x to the 3r minus 12. And that is what I want to eventually become x to the 9th. So really what I'm trying to solve is 3r minus 12 equals 9. So if 3r minus 12 equals 9, I end up with 3r equals 21, which means r must be 7. So now that we've figured this out, that's the exponent that's missing, we can now actually do the coefficient question. So we will start with 12, choose 7. We could also do 12, choose 5, because it's the same value. And then we're going to have x squared to the 7th, and we're going to have 4 over x to the whatever's left over, which is 5. So the 12 choose 7 is 792. And then we have, of course, x to the 14th. And then 4 to the 5th is 1024. And then we're dividing that by x to the 5th. And we're multiplying that all out. And when we multiply the 792, there's a 1024. We end up with 811008. And of course, x to the 14th over x to the 5th is x to the 9th. Now the question wanted the coefficient, so the coefficient of x to the 9th is 811008. So again, what I did was I ignored the coefficient question temporarily. I just wanted to figure out what exponents I would need to get my x to the 9th, which is what they want eventually. So I said, okay, well, I'm going to have some amount of x squared, so let's say x squared to the r, and then some amount of 4 over x's. Well, that's whatever's left over, since I was supposed to end up with 12 as the final exponent. If this is r, then this has to be 12 minus r. And so then I ignored the 4 again, because that's part of the coefficient. And I just worked with the x squared to the r and the x to the 12 minus r and simplified that by subtracting exponents carefully. And then once I had that expression with the exponent written out, I knew that expression had to equal 9 because that's what I'm trying to get. So I then solved that, figured out what r was, and that's when I went back and actually worked out the coefficients by plugging in 12 choose 7, etc., and getting my final answer. Now you'll notice again here that I did not round to 3 sig figs because these are the exact coefficients that we're trying to find. So we're going to not follow the 3 sig fig rules at this point. So now let's find the constant term of this expression. So again, I'm going to ignore the fact that there's going to be coefficients temporarily, and I'm going to focus on the exponent of x. Well, if it's a constant term, that means I ultimately want to get x to the 0. So I do the same setup where I say, okay, I know there's going to be an x squared to the r, and I know there's going to be 4 over x to the, in this case, 12 minus r to finish off to get my 12. And I know there's a coefficient which I'm ignoring, and I'm also going to ignore the 4 to the 12 minus r temporarily, carefully and focus only on the x's. So I basically get, again, x to the 2r over x to the 12 minus r, and I do the subtraction of the exponents. I'm going to get this eventually. So x to the 3r minus 12 is going to have to equal, well, it's going to have to equal x to the 0, so that what I'm looking at is the constant term. It should not have x, so x to the 0. And so I solve 3r minus 12 equals 0, and of course that's going to be r equals 4. So now we're ready to actually calculate the coefficient. So really what we want is 12 choose 4. We could also have used 12 choose 8. That would have been fine. And then we want x squared to the 4, and then 4 over x to the whatever's left over, which is 8. Now, 12 choose 4 turns into 495, and then x squared to the 4th is x to the 8th, and then 4 to the 8th is 65536, and then over x to the 8th. And of course, the x's will cancel, which is what we wanted. And this gives us 32,440,320. And of course, this already is the constant term because there's no x in it, so I don't have to change the way I write my answer to talk about a coefficient. That is the answer. All right, find the coefficient of x to the 5th in this expansion. Well, there's more than just a binomial. This is a binomial to the 6th, and this is just some separate factor. So I got to think about that a little more carefully. So let me start with the x plus 3. And then there's going to be some kind of expansion here, ... plus. Now, ultimately, I have to distribute the x in. And then afterwards, I also have to distribute the 3 in. And when I'm done, I need to get x to the 5th. When I distribute the x in, I'm hoping to get x to the 4th in here, because x times x to the 4th will be x to the 5th. When I distribute the 3 in, I'm hoping to get x to the 5th in here, because 3 times x to the 5th will be my x to the 5th. So I need both the term that has x to the 5th in it and the term that has x to the 4th in it. So to get x to the 5th, I would have had to have done 2x raised to the 5th and then negative 1 to the 1st, so that I end up with my 6 total using the 2x and the negative 1. So this leaves me with a coefficient now, binomial coefficient, of 6 choose 5 or 6 choose 1, it doesn't really matter. Plus, now to get my x to the 4th, so I'll get the x times x to the 4th, I need to have 2x raised to the 4th, and I have to have negative 1 squared. That way I get my 6. And then I need my coefficient here of 6 choose 4 or 6 choose 2. It doesn't really matter. Plus, there's a whole bunch more terms that really don't matter because I'm not going to end up with my x to the 5th when I'm done. Now, again, I needed 2 terms from here because I need an x to the 5th out of it and I need an x to the 4th out of it. So when I distribute the appropriate one with each of these, I end up with x to the 5th when I'm done. So now let's use the calculator to work these things out. Now 6 choose 5 is just 6, and then I multiply by 2 to the 5th, and then times negative 1. So this is minus 192 x to the 5th. Now for the next one, 6 choose 4 is 15, and then 2 to the 4th is 16, and then negative 1 squared is just positive. So 15 times 16 times 1 is 240, and of course that gives me x to the 4th, plus ... And of course, don't forget I'm still distributing x plus 3. Now again, to get my x to the 5th, I have to take this x times this, and then this 3 times that. So I want, again, ... 3 times the negative 192 x to the 5th, plus x times the 240 x to the 4th, plus ... of course. And so here, when I do 3 times negative 192, I get negative 576 x to the 5th, and then plus 240 x to the 5th, plus ... And now I combine like terms, and I end up with negative 336 x to the 5th. And so the coefficient of x to the 5th is negative 336. And that is the end of the lesson.